All right, so here's a really interesting question that I got the other day, and I just wanted to show you how I go about solving it. This question wanted us to find the local and the end behavior of this function right here. So basically, I could really see it easier if I could sketch a graph of it. So that's what I'm going to try to do. And to sketch that graph, I'm going to try to get a couple of key pieces of information. One thing I would like to know is if there are any vertical asymptotes. Those vertical asymptotes come about because of zeros in the denominator. If you remember, that's one of the domain problems that we'll have with rational functions like this, that is zeros in the denominator. We don't want them. So to see where that will happen, we'll let the denominator equal 0. If I move over the 1, that'll be a negative 1. And then if I divide out the 2, that'll be a negative 1/2. So this is where we're going to get, this is where we're going to get a vertical asymptote right there. So at a point, and I'll just draw it right here arbitrarily, this is where we're going to get a vertical asymptote. We would also like to know if we have any horizontal asymptotes. They are possible. This is where you have to refer to your rules and see that if the degree of the top polynomial is the same as the degree of the bottom polynomial, as it is here, then you're going to have a horizontal asymptote. So we'll actually get a horizontal asymptote when the degrees are the same. We'll get a horizontal asymptote using the leading coefficient of both the top and the bottom. Leading coefficient is 1 on the top and it's 2 on the bottom. So our horizontal asymptote is going to be at y equals 1/2. So if this is 1/2 right here, this is where we're getting our horizontal asymptote. All right, so that's some good pieces of information. Another good piece of information would be if we could find the x and y intercepts. So if we're doing that, let's first start with the y-intercept. This is going to happen when we let x equal 0. If we let x equal 0, then the function evaluated at 0 is going to equal, as a practice, I like to put my parentheses. Now I'll plug in the 0, and I see that I get 0 over 1, which is equal to 0. So the y-intercept is going to be there at the point 0, 0. And that's right here. That's the origin. If I want to do the x-intercept, let y equal 0. So that means you let the entire function equal 0, and then you solve for x. In this case, you're going to want to cross multiply this over. 0 times anything is still 0. So all you're left is with x is equal to 0. So when x equals 0, y will equal 0. That's still that same point right here at the asymptote. Excuse me, not the asymptote, at the origin. So this is showing me, with these key pieces of information, I can see that I'm going to have graph on this side. Asymptote is not going to let us cross, so it's going to come up to hit this and then just keep going this way, never crossing that 1/2 line. And then that means that this is going to pop out over here, and it's never going to cross that, so we're going to go like this. And there's our nice little graph. From the graph, I can see the end behavior. These are my end behaviors, so I can write it out like this. As x approaches negative 1/2 from the positive side, in other words, as it approaches this number from this side, f of x is approaching negative infinity. You see that? It's going to negative infinity, the y part. On the other side of it, as x approaches negative 1/2 from the negative side, f of x is approaching positive infinity. Do you see how as we get closer to that negative 1/2, the y keeps going up and up and up? So that's the positive infinity part. So that's the local behavior. The end behavior is out here and out here. And as we can see, as x approaches positive infinity, f of x approaches the 1/2. Same thing on the other side. As x goes to negative infinity, f of x goes to 1/2. And so that's how that works. That's how we find the local and end behavior. At least that's how I do it on this one. If you do it a different way, if I made a mistake, by all means, let us know in the comments, and I'll talk to you later. Bye.